Our intent was to eventually leave these buoys out in the wintertime so we can collect wintertime data, and especially water temperatures under the ice. But we weren't planning to do that until like next year or the year after. So this year froze in early and we didn't have time to get off the lake. And so what we're going to do is rig it up with some heftier battery power to get it through the wintertime.
Good afternoon, my name is Nachum Akram, and this is a Bass Saturday Talk out in the field. Today I'm out with John Lenters. We're out on Freshwater Lake here in Barrow, Alaska. The idea is to put new batteries in the buoy so that they can last and send data back throughout the winter.
Hi, my name is John Lenters, and I'm an associate professor at the School of Natural Resources at the University of Nebraska in Lincoln, and also a senior scientist with Limnotech in Ann Arbor, Michigan. And we've got a buoy up here in the Arctic that's been measuring water temperatures on this lake for the last couple of years, along with a bunch of different weather sensors that measure solar radiation and infrared radiation and reflectivity from the snow, and a couple sensors there that measure wind speed and wind direction, as well as air temperature, humidity, and barometric pressure, and also rain. So what we've got is a system that froze in this year, and we're trying to get the batteries rigged up to make it through winter. The solar panels and battery that are on here so far, we attached an extra one in August because we knew it was going to be in kind of late, but that's not nearly enough to get it through winter time, which was intended to be next year, but lake froze about 2 weeks early this year, at least 2 weeks earlier than we expected. So it kind of caught us off guard, but came out on thin ice to give it some new juice. One of the main reasons we have this buoy out here is to measure evaporation rates, and evaporation is it's a process that's a little bit difficult to measure. We have sensors like this one up here that measures the amount of rain hitting the top, but you can't really measure the amount of water vapor leaving the lake directly, so you have to measure it indirectly. So we have all these sensors on here that measure energy, like solar energy coming into the lake. We have a temperature string that goes down into the lake right under the ice right now that's measuring temperature every 25 centimeters, and it measures the change in heat content in the lake, change in water temperature essentially, or if there's ice forming. And from that change in heat content and the amount of energy coming into and out of the lake, you can measure evaporation rates. What you do is essentially measure every other energy component and then subtract and solve for evaporation. Evaporation is a cooling process, as you know from when you sweat, your body cools. And so we measure that cooling process from evaporation, but to measure it we have to measure all these other different parameters. So that's one of the primary goals of the project. Now that the lake is frozen, you can imagine there's not really a lot of evaporation going on. It's really all the energy that's being lost is going into thickening the ice. Fortunately thick enough that we could walk out on it today. It thickens at about a rate of 1 centimeter per day on average over the entire winter. So one of the things we can do with the water temperature sensors that are now under the ice is we can measure how quickly that ice thickens, and we can also measure the amount of heat released from the bottom of the lake. The lake is actually quite warm underneath the lake from the summertime. It's stored all that energy, and it's now releasing it back into the water column. And so if you measure the water temperatures under the ice right now, they're actually warming up. It's about 25 degrees Fahrenheit right now. The ice is around freezing, but underneath the ice it's actually above freezing and getting warmer, and that's because it's sucking that heat out of the bottom of the lake. Now eventually in the dead of winter that's going to start to turn around, and the lake will cool off, the ice thickens, and eventually it gets down to almost 2 meters thick, or about 6 feet. And that happens about late April is when the ice reaches the maximum. And then we get back out here in April, drill some cores in the ice, measure the ice thickness, measure the snow depth, and a few other parameters. We'd make water samples and things like that. So anyway, that's what this guy is doing, and if we don't get batteries connected now, it's going to die out on us. It's probably tonight. So just rig it up with some heftier battery power to get it through the winter time. So this year froze in early and didn't have time to get off the lake, and so what we're going to do is rig it up with some heftier battery power to get it through the winter time. Get it through the winter time. Get it through the winter time.